Hi, in this session we are going to discuss one particular example on how to use and implement recursion. The problem is the countdown, which is to write a very short program in which we start counting down given a positive integer n, and we print the values. In other words, if the value n is 10, what we want to print is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, it's a simple problem that can be solved with a loop, specifically with a for or a while loop. But I want to use this very simple concept to introduce how to write a recursive solution. So if we decide to apply recursion, the first question that we should answer is, what is the base case of this problem? And if you remember from previous videos, the base case is a problem that is related to the original problem, but it's smaller in size so that we know the answer. Well, obviously, if the countdown starts at 0, there is no countdown. We simply printed the value 0. If the countdown starts at 1000, then it's going to be 1000 numbers that we need to display. So the base case, the problem that I know to solve, is specifically when n is equal to 0. I know the answer to that. So if I switch to the code that I'm trying to write, I'm trying to write now a method that I call descending order, that it takes a value n, and value n is the initial value of my countdown. So I can say in my code, if n is equal to 0, then all I have to do is simply to print that value. That is my base case. Else means, well, n is not 0, so I need to apply recursion to solve this problem. So the next step, in addition to the base case, is to reducing the size of the problem and making the recursive call. So those two generally go hand in hand. So what is reducing the size of the problem? So assuming that you don't know how to count down from 3, you can say, well, I know that that is 3 plus counting down from 2. And then counting down from 2 is 2, and counting down from 1. And again, counting down from 1 is similar to 1, and counting down from 0. And eventually we get to the base case, which is 0. So what I have to do is just print the value, basically. I'm going to print 3, 2, 1, and eventually 0. And as long as I am not at the base case, which is printing the 0, then I need to make a recursive call to count from 2. So I subtract 1 from the initial value. So these steps in here that I explained in English are exactly what I have in these two statements. So the else part is, I don't know what the base case is, so I need to do two things: make a recursive call and reduce the size of the problem. So what I'm going to do is, the first part is to print the current value of n. Like in here, I print 3, and then I need to figure out how to count down from 2. I print 2, how to count down from 1. And that is simply a recursive call to the same method, descending in order, and subtract n from 1. So this part here does the printing, this part here does the recursive call and reducing the size of the problem. Let me show you how this works once it's implemented in an application. So here I have a very simple program. I am in my method main, and all I do in the method main is to call my method descending order with value 6. So what I want to do is to print 6, 5, 4, 3, 2, 1, 0. So here is the method called descending in order, and as you can see, there is an if-else. The if is the base case, what I know how to solve. Basically, count down from 0. So when n is 0, all I have to do is to print the value of n, which is 0. If it's not 0, what do? I print the value that is given to me, okay, and that happens to be n, and then what? I make a recursive call to descending in order, and I subtract 1 from the value of n, which reduces the size of the problem. So as you can see, asking now the computer to start with the value 6 and then count down. So 6, 5, 4, 3, 2, 1, 0. So if I want to trace this, the first time I call descending order over 6, the value of n is 6, is not 0, then I go to the else part. And the else says, print the value of n. Well, the value of n is 6, so I print 6. And then what? Make a recursive call with n minus 1, 6 minus 1, which is 5. So the second time around, my value of n is going to be 5. And again, is not 0, so I go to the else, and what do? I print the value of n, which happens to be 5, so I here get 5. And then descending order with 4, and then 3, and then 2, and then 1, and eventually n is going to be 0, right? So this statement will be true, in which case the last value to be printed is 0. This is consistent with the discussion in our Word document. So this is the word descending in order. One interesting observation of recursion that you need to understand is what would happen if we reverse the order of these two statements. In other words, what happens when we are not on the base case, and then instead of printing the value, which what I want to do to print the countdown, I make the recursive call first and then print the value. What that's going to do is going to postpone printing all the values. So instead of counting down, I'm going to count in increase in order. So instead of going 5, 4, 3, 2, 1, it's going to be 1, 2, 3, 4, 5, because I'm postponing the printing. And that's one of the advantages of recursion. So let me show you again the method that we were trying to write called descending in order, right? And we already know that this is going to give us the correct values, 6, 5, 4, 3, 2, 1. Now what would happen again if we change the order of these two statements? In other words, we're going to make the recursive call and then we're going to print the values. What that happens is we are going to start at 6, decrease the values until we get to 0, and then start printing and then backtrack. So it's going to print 0, 1, 2, 3, 4. In other words, in increasing order. But this is a powerful tool that we have in recursion, which is reversing some of these statements could produce the opposite result. So here clearly we are counting in increasing order, 0, 1, 2, 3, 4, 5, 6, simply because we reverse the order of these things. And again, if we go back to the original solution, then it prints in reverse order, which is a countdown. Very powerful tool to have, and it's one of the interesting properties of recursion.